Thank you. I hope you can hear me well.
Yes, everything is working.
Perfect. So let's start our webinar. And today we are going to speak about methane detection. This is not the first time when we speak about methane detection with drones. Last year we had another webinar where we introduced our solution together with our partners from Pergam. And at that time, we introduced the sensors that you can see on your screens. This is a handheld sensor, which is equipped with LED screen and battery, adapted for drones. That was last time, and we got a lot of positive feedback about the product, about the solution, and we realized that there are many applications where methane detection can be quite useful. Of course, this is a natural gas pipeline, landfill emission monitoring. Basically, this can be very handy for different industrial objects which connected to gas transmission and gas storage. And again, we got a lot of positive feedback, but we realized at that time that, okay, it would be nice if the sensor could be a bit lighter and the range could be a bit bigger. And today we are very happy to announce our new integration with another sensor from our good friends from Pergam. This is a Pergam Laser Falcon. And this sensor is specially designed for integrations. So it doesn't have a battery, it doesn't have a screen, it's lightweight, and it has a better range. And what we did, we integrated the sensor into our existing solution. Specifically, we integrated it with our SkyHub data onboard computer. And of course, we integrated the sensor with all our software. And now you can use it with different types of drones. Of course, we tried to make it available for most popular flying platforms like DJI M600, DJI M600 Pro, A3-based drones, the M series, but not all the M200 drones, but M210 and M200 V2 only. And of course, for this new DJI M300, we are going to enable support for this drone in June. Also, the solution can be used on autopilot-based drones. Now, we are going to show you how the sensor can be mounted on the drone, and then we will demonstrate you the software. So the boring part is over. I'm going to switch to another video feed. 1 second. I hope you can see it now.
Yes, it's connected.
Okay, great. So, and my colleague will show you how the sensor and actually entire system can be mounted on the drone. We have DJI M210 version 2. So yeah, please proceed. when we designed the solution, we tried to make it easy to install, because deployment time is always important. You cannot spend too much time for that. And so the yellow box is a sensor itself. The black box is our data logger, and also drone equipped with a standard DJI camera X5S. And later we will show you how you can combine the measurements from the sensor and the video feed. The sensor doesn't have any battery, so we provide the power supply from our onboard computer. An onboard computer, it serves for the following main purposes. First of all, it serves like an onboard data logger, which records all the measurements from the sensor along with GPS data. And what is important, if your drone is equipped with RTK receiver, then you will get a very accurate georeferencing. Also, data logger allows you to stream measurements from the sensor over the DJI standard data link to the ground. And we will demonstrate you later how you can receive these measurements during the flight. So now, as you can see, it took maybe 2 minutes to mount the system on the drone. And it's quite easy, it's lightweight, can be deployed in the field, and very suitable for transportation. Okay, thank you very much, Crucianis. So now we are going to move to the next part and demonstrate you the software itself. So I will ask Yanis to set up the streaming from the drone and turn it into simulator mode. And I will show you several slides in my presentation, and then we'll switch to the software demonstration. And because, as you can see, I'm not in the office, so I will show you the software which will use the data from remote drone. We will use the data streaming over the internet. So it's also a very interesting thing. So let me share my screen again. Okay, I hope again you can see the presentation. And now let's switch to the flight planning part. Of course, the flight planning itself, it depends heavily on the sensor capabilities. And in case of Laser Falcon, we have the following key parameters which affect every flight plan specifically. The recommended altitude is around 30 meters. The maximum altitude for the sensor is 100 meters, but of course the quality of measurements significantly drops after 50 meters. And the sampling rate is 10 Hertz, meaning that sensor makes 10 measurements per second. And these may affect the flight speed of your survey. So we have this very quick calculation that you can use for planning your surveys. So for example, with 1 meter per second, you will get measurements every 10 centimeters. And with 5 meters per second, you will get measurements every 50 centimeters. So you can use this simple spreadsheet for planning. Just have it somewhere nearby. And as I mentioned before, the software that we provide as a part of the solution is fully integrated with the sensor. And it consists of several parts. It consists of our ground control software, the UgCS ground control software, and I will, yeah. I hope you can see my screen with the software. Can you see it?
Yes, the software,
Okay.
your camera also is on.
Okay, that's good. Okay. Yeah, great. So let me I'm just slightly changing the layout. Okay, so on the left part of the screen, the biggest part of the screen is our ground control software, UgCS. It can be used for flight planning, for different types of surveys. And in case of methane detection, typically you might want to plan 2 types of surveys. The first survey is the aerial survey. So you might want to define some perimeter that you want to inspect. And in UgCS, it can be done easily. As you can see, we have a 3D map that allows you to plan very accurate surveys with elevation data. Also, if you wish, and if you have this data, you can upload your custom maps. And in this particular case, as you can see, I have a base map and I have an overlay, which I uploaded to the software for more accurate planning. So for aerial survey, I can use the area scan tool and I can draw a polygon, basically of any shape. And in one of our previous webinars, we received a question: can we use non-convex shapes for flight planning? And the answer is yes, of course, you can. So as you can see, this is a pretty complicated shape. I specified the flight height for 50 meters, the side distance 2 meters, meaning that you will have passes every 2 meters. And as you can see, we have a flight plan with terrain following. So you fly on a constant altitude above ground level. And this is the first type of the survey. We have a lot of materials on our website and our YouTube channel about flight planning, so I don't want to spend too much time for that right now, but maybe the only thing that I want to show right now is another type, the second type of survey that can be very important for methane detection, when you need to fly along the linear object. And for that, I will create another route. And I also want to show you that, for example, when you get when you get a job to fly along linear object, you may receive some initial coordinates of your object, for example, in TML format. And in this case, you can easily import this KML file as a root to UgCS. So, yeah, this is how this can be done. And again, you can fly with terrain following. You can change the route if you like, but that's pretty fast way. If you have some initial data, initial geometry, that's a pretty fast way for building your flight plan. Okay, let's look at another windows. In the upper right corner, we have a video player which demonstrates the online video from the drone, from the X5 camera attached to the drone. And as you can see, this video has metadata in it, coordinates, the latitude, longitude, heading of the camera, pitch value, and also in this rightmost field, you can see the value from the Methane detector attached to the drone. In the window that, in the section that is in the bottom right corner, you can see the measurements, current measurements of the Methane sensor. In case of this sensor, you receive like a ppm per meter. So number of particles per meter of measurement. Of course, in our office, the concentration of methane is low. That's why we see these values, very small values. But you can compare with slight delay, you can see the same value in video window and in our custom payload monitor. And that can be very useful when you need not just to see online values during the flight, but you might also want to record the video feed from the drone, the measurements from the sensor in parallel, and keep them synchronized. So for example, I will maximize the window with our video player. So we can press start recording. And during the flight, you will make a recording of the video feed from the camera and also geographical information and measurements of the sensor. And after the flight, you can use this video as a kind of report. This video is recorded in the format which some of you might know under the name full motion video. This is a format that can be imported into such geographical information system like ArcGIS. And it can be replayed in the system and analyzed. Also, this video can be replayed in our own player. I will switch to recorded videos. And here it is. So we can replay it. And also I can open the metadata screen where you can see that for every frame in the video, we have associated metadata. So sensor latitude, sensor longitude, azimuth of the sensor, and also the value of the sensor. This is how the system looks. This is how the system looks like right now. And of course, in this screen, I mean custom payload monitor, you can configure different thresholds, which will indicate you when, for example, current measurement of the sensor hits a certain threshold, which may indicate the leak of the gas. So let's, for example, let's try to upload the root. Let's try to upload the root to the drone, and I will, of course, in simulation mode, yeah, I will show you how the drone is flying and how the metadata in the video is changing. So you can see the GPS coordinates in the video feed constantly changing and recorded. Okay, now let's get back to our presentation. So just to recap quickly, so what which components comprises the solution? First of all, of course, this is a UgCS flight planner. The second thing, which is in the kit, is not onboard data recording with georeferencing with our SkyHub computer. Also, you get in-flight online sensor data streaming to the ground. Also, you may configure online video streaming with video recording with embedded GPS and sensor data. Also, I would like to say that because our SkyHub platform is quite universal and it is suitable for connecting not only methane detector but also other sensors which are part of our industrial solutions product line. You also can benefit from connecting a true terrain following kit to the drone, which is an altimeter helping the drone to keep a constant altitude over the real terrain. And this kit is also compatible with our methane detection kit. Also, all the information about the solution and methane detection sensor that we propose can be found in our industrial.ugcs.com in the methane detector section. I think that's all, and now I'm ready to answer questions, if we have any. Let me check the Q&A section. The question from Melissa. Yes, in the user interface, it is called ppm. So the question is the following: your value is ppm, but doesn't the laser Falcon provide ppm per meter? Yes, you're absolutely right, and that's what I said. In user interface, it is called ppm. We will change it to ppm per meter, because in reality, of course, it returns ppm per meter. Another question, the tool that links the sensor with ground station on UgCS is developed on the basic version of UgCS or is only available on a special version. We typically ship the integrated kit consisting of the sensor itself, data logger computer, UgCS enterprise or professional version, and a special software for monitoring sensor data in real time. If you don't need a video streaming, we have an option with UgCS professional version. If you need online video streaming, then you may choose the version with UgCS enterprise, which contains this video streaming function. But of course, yeah.
But the UgCS is the ordinary UgCS, so you don't need a special UgCS version for mission planning when you use methane detector.
Yes.
It's the ordinary UgCS. Mm-hmm.
Yes, and also one important note, and if you, for example, if you already have a sensor that we do support, then of course you don't need to purchase another sensor from us. You may just ask, you may just request everything except the sensor, the data logger, SkyHub, and the necessary software. Another question from Samuel. How are the measurement results if you have a situation with relatively dense ground vegetation? Example, bushes. Of course, so the measurement is based, uses a laser beam. So if there is an obstacle between the laser beam and particles of the methane, then of course the measurement results may be not very good. But if the concentration of the methane is significant and you have particles of the gas in the bushes, in the leaves, then you will detect for sure.
Sorry.
Yes,
we have also some questions, many questions, more than once. The question: is the system already ready, available? Can we purchase already now?
Yes, yes, you can order. The lead time now is around from 7 to 8 weeks. That is primarily because of the lead time for the sensor. So this is, yeah, and we have a question from Gustavo, how the sensor affect the gravity center point of the drone. It's not heavy, actually. It's around, the whole system is less than half of a kilogram. So, and it is mounted very close to the center of the drone. So I would say that it doesn't affect that much. Good question from Steve. Are you still using the LMM methane sensor or anticipate to switch to the Falcon completely? I would say that these sensors, they are very different. So we still support LMC, and we are not going to stop discontinue support because it's a working configuration, and the LMM sensor is good when you need to use it not only for drone-based surveys, but also for just a regular manual surveys. And you need all the things that it has, like a LED screen and battery. So I would say that depending on your use case, you might want to use the LMM or Falcon. But for a drone-based solution, of course, Falcon looks more suitable.
Sorry, we have an interesting question here in chat. Is the kit, the UgCS SkyHub kit, compatible also with the other sensors? So you can use this one kit and then exchange the sensors, for example, GPR, magnetometer. You don't need to buy for each sensor a different kit from UgCS, correct?
The onboard computer will be the same. You might need to use different firmware for different sensors because, for example, for ground penetrating radar, there's one functionality. For methane detectors, slightly different functionality. But the onboard computer can be the same. Yeah, it is the same, just with different firmware. Another question from Felipe. Do you have a dealer in Latin America? We have a broad list of resellers, so we can send you the list of our resellers separately. Also, again, our partners from Pergam also have several offices in the world, and also they have resellers. So you can drop us a message, and if you wish to be a dealer, drop us a message. If you wish to get a solution for your own usage, drop us a message, and we'll definitely assist you. We'll find a best way how to help you with your inquiry. The questions: do you require the terrain following kit with methane sensor to follow a specific areal? Very good question, thank you. So we do not include the terrain following kit in the methane detection kit because for many cases you can fly just using your onboard altimeter and use UgCS with digital elevation model to plane accurate surveys. If you need an extra, and methane detector is not that sensitive to like a sub-meter accuracy of the altitude. So we would say that if you think that following terrain, real terrain with sub-meter accuracy is important for you, you can get this terrain following kit. But in my opinion, you can begin without this kit and purchase it later. Okay, the question from Sergey. Is there any influence of the air turbulence from rotors on the methane readings? Again, great question. So no, in most cases, no. Because in most cases you will fly on the altitudes like 20 or 30 meters above the ground, and at that altitudes there is no influence of the air turbulence from rotors on the measurements. So okay, the question about confirmation of the metrology of the measurements. Okay, that's a good question, because what we this sensor, it's a not measurement instrument, and the measurement values, they are not in ppm, but ppm per meter. This is not a measurement tool, this is a detector. It cannot be used for measurement, but it can help you to quickly identify the leak. So that is why there is no methodology, and the measurement values, they cannot be used to calculate, for example, the concentration of the gas in some volume. Then, question from Tom. Can you run multiple sensors like methane and magnetometer at the same time? Yes. Of course, this will, most probably this may work for DJI M600 drone, because you need some space on the frame to mount all these things. But technically, one data logger can work with several sensors. I already own LMC. A question from Don. I already own LMC. Can I just purchase the UgCS conversion and software? Can I use the UgCS on either M600 series or M200 series? So yeah, typically, if you already have LMC sensor, we propose the following procedure, again, together with our colleagues from Pergam. You can send us a message and we can tell you whether the sensors can be converted into the drone-based sensor. In most cases, yes. Then, with the help of, we will need to find the closest to you Pergam representative who will help you to convert the sensor. And then, yes, if conversion is successful, then you can purchase just the data logger and UgCS software and use your existing sensor with your M600 drone. And again, in case of M200 series, I want to stress your attention that we can work only with M210 and M210 version 2, because ordinary M200 doesn't have onboard DJI onboard SDK port that we use to for communication between our SkyHub and the autopilot. So just keep it in mind. Is the mounting mechanism similar for M600 Pro and M210? And is the mounting included in any version of the kit? No, it is not the same. We have two different mechanisms. Yes, it is included in the kit. The question from David, if I already have a SkyHub, would it be as simple as a software update to gain Falcon compatibility? Yes, yes. The computer, the SkyHub will be the same. You need just to get the latest firmware update. The question from Mel, I'm not sure if I got it right. What maps can be imported? Basically, in UgCS, you can import GeoTIFF with mapping data, and also you can import digital terrain models in GeoTIFF or also in several other formats. I hope that answers your question. The question from Michael: how is the GPS calculated if the sensor is not aligned nadir during the flight? Now we record the position of the drone at the measurement point, so we do not try to make a kind of a ray tracing and try to find the intersection between the beam and the Earth surface. So in most cases we recommend to, and thus in most cases we recommend to mount the sensor looking straight down. Thus will allow you to use the latitude and longitude of the drone as a position of your leak. The question from Sasa. What is the field of view or scan width of the methane sensor? Typically, the methane sensor, it is not the scanner. It measures, it tries to detect the methane just in the spot. So basically, we cannot speak about the size of the footprint because it is very small. So just consider it as measuring, as detecting methane in the spot. The question from Tom: can you plan a survey route in ArcGIS or AutoCAD, then import it into UgCS? UgCS allows you to import geographical path information in two main formats. So you can import in KML and you can import in CSV. If you can export your route information into one of these formats, then yes, then you can import into UgCS and use that information for flight planning as a basis for your flight planning. The question from Melissa: is customer service for the system available by phone or only by email? We have email support. We also have a phone number, and yeah, you can call us if you have any questions. I think I answered all the questions.
Great, thanks to you, and let's meet in another webinar. We will keep you informing about the series of UgCS functionality which we plan to show, and also other products which we are planning to launch very soon. So thank you very much. Thank you, Alexei, and
thank you.
Let's get back to our everyday life. Keep safe.
Bye-bye.